In this lecture, we will discuss the introduction of transportation problem. What is the transportation problem? Transportation is physical distribution of goods and services from several supply centers to several demand centers, which means transportation is the distribution of goods and services from m number of supply centers to n number of demand centers. Here, supply centers also known as sources or origin. Similarly, demand centers also known as destination. Then objective of the transportation problem is determine the number of units of an item which should be shipped from origin to a destination in order to satisfy the required quantity of goods or services at each destination center within the limited quantity of goods or services available at each supply centers at the minimum transportation cost. Next, we have to look for the mathematical model of transportation problem. First, we will see the how to represent the transportation problem. In general, transportation problem is represented in a m by n matrix. Here, m equal to the number of rows and n equal to the number of columns. Here, supply centers are represented in rows and demand centers are represented in columns. And elements of the matrix are the cost of transportation 1 unit from ith origin to jth destination. This is represented by the Cij. And another elements are the quantity of the transportation 1 unit from ith origin to jth destination. This is represented by the Xij. Let there be m sources of supply, that is S1, S2 up to the Sm, having the Ai units of supply respectively to be transported to n destination, that is D1, D2 up to the Dn with Bj units of demand respectively. Let Cij be the cost of shipping 1 unit of commodity from source I to destination j. Let Xij represents the number of units shipped from source I to destination j. Let's see the how to represent a transportation problem by this given data. We know that supply centers or origins are represented in rows, that is S1, S2 up to the Sm rows. Supply value is the A1, A2 up to the Am for corresponding supply centers. Similarly, demand or destinations are represented in columns, that is D1, D2 up to the Dn columns, and demand value is the B1, B2 up to the Bn for corresponding demand centers. Supply Ai equal to the summation of A1 plus A2 plus up to the Am, and demand Bi is the summation of B1 plus B2 plus up to the Bn, and Xij is the quantity transportation from ith origin to jth destination, and Cij is the cost of transportation from ith origin to jth destination. Next, to see the how to represent the transportation problem by mathematically. Objective of the transportation problem is minimize the transportation cost. Then minimize Z equal to summation of J equal to 1 to M and summation of I equal to 1 to N Cij into Xij, and the constraints are summation of J equal to 1 to N Xij equal to Ai and summation of I equal to 1 to M Xij equal to Bj. Here I equal to 1, 2, 3 up to M number of supply centers and J equal to 1, 2, 3 up to N number of demand centers. Then there are M plus N constraints, one for each source of supply and destination, and here variables are the M into N variables. Next we have to look for the classification of transportation problem. In general, transportation problems are classified into unbalanced transportation problem and balanced transportation problem. First we have to look for the what you mean by balanced transportation problem. If the total demand equal to the total supply, in this condition we are calling as the balanced transportation problem. We know that when the total demand is the summation of J equal to 1 to N Bij and total supply, which is the summation of I equal to 1 to M Ai. So total demand equal to the total supply we are calling as the balanced transportation problem. This condition also we are calling as the rim condition, where the total demand equal to the total supply. This condition we are calling as the rim condition. Next we have to look for the unbalanced transportation problem. In general, unbalanced transportation problem arises demand is greater than the supply or maybe demand is less than the supply. First we have to look for the demand is greater than the supply. So total demand, that is summation of J equal to 1 Bj is greater than the total supply, that is the summation of I equal to M Ai. In this condition we have to add a dummy row with cost 0 and supply equal to the demand minus supply. Next, second condition, demand is less than the supply. So total demand is less than the total supply. We know that one, total demand equal to the summation of J equal to 1 to N Bj is less than the total supply, which is summation of I equal to 1 to M Ai. In this condition, when the total demand is less than the total supply condition, we have to add a dummy column with cost 0 and demand equal to the supply minus demand. We have to look for the example problem for the unbalanced transportation problem. First we have to look for the demand is greater than the supply. In the given problem, total demand equal to the 10 plus, 50 plus, 30 plus 20 equal to the 110 and the total supply equal to the 30 plus, 40 plus, 20 plus 10, which is equal to the 100. So demand is greater than the supply. Then we have to add a dummy row with 0 cost. And supply value for this dummy row is the total demand minus total supply, that is 110 minus 100, which is equal to the 10. Next we have to look for the another condition, demand is less than the supply. So in the given problem, total demand equal to the 10 plus, 20 plus, 30 plus 40, which is equal to 100, and total supply equal to 50 plus, 20 plus, 10 plus 30, which is equal to the 110. So here total supply is the 110 and demand is the 100. Then demand is less than the supply. In this condition we have to add a dummy column with zero cost, and demand value for this dummy column is total supply minus total demand, that is 110 minus 100, which is equal to the 10. Next we will discuss the different types of solutions for a transportation problem. First one is the feasible solution. Any set of non-negative allocations which satisfy the rim condition is called a feasible solution. What do you mean by rim condition? In the rim condition, total demand equal to the total supply. So in the feasible solution, set of non-negative allocations should be satisfy the total demand equal to the total supply. Such a solution we are calling as a feasible solution. Next one is the basic feasible solution. Basic feasible solution is a feasible solution. Here set of non-negative allocations should be satisfy the total demand equal to the total supply. Moreover, it contains no more than the m plus n minus 1 non-negative allocations. So in the basic feasible solution, it should be a feasible solution. Moreover, allocation should be no more than the m plus n minus 1. Next one is the non-degenerate basic feasible solution. Non-degenerate basic feasible solution is a basic feasible solution, and it contains the allocations exactly m plus n minus 1. And moreover, these allocations, these m plus n minus 1 allocations are in independent position. What do you mean by independent position is, if it is impossible to form a closed path, which means these allocations is not possible to forming a closed path. So what do you mean by closed path? Mean a path which is formed by allowing horizontal and vertical lines and all the corner cells of which occupied cells called a closed path. So it is the schematic representation for the independent position and the not in independent positions. First we have to look for the not in independent position. Here I have to observe that one all the allocations are forming a closed path. See here, all these three paths are forming a closed path. So these type of path we are calling as not in independent position. Second one, we have to see in these two tables, these are the examples for the independent positions. Here observe that one all the allocations are not forming a closed path. So here also not forming a closed path. So next one is the optimal solution. Optimal solution is a feasible solution which minimizes the total cost. The solution of a transportation problem can be divided into the two stages. First one is the initial and second one is the optimal solution. Initial solution can be obtained by the following the three methods, that is the northwest corner rule, least cost method, Vogel's approximation method. In general, VAM method, that is the Vogel's approximation method, is preferred among the another two methods because this VAM method provides the initial basic feasible solution which is either very close to the optimal solution. So next one is the optimal solution. Optimal solution is the improved solution of the initial basic feasible solution, and which is the second stage of solution, and this can be obtained by the modified distribution method. In general we are calling as the MODI method.